Hello everyone, I'm Alan, and also known as McLaren 2009, and today I'm playing Stormworks. I'm going to be walking you through how to use my TACAN system. It's recently been updated to change the actual interface for it, so I want to show you the changes that I've made to it. So we're going to spawn in this really basic test cart. You don't really need a cart, you really just need power, a platform, and something to actually put the system on. So, what TACAN is it means Tactical Air Navigation. Basically, something will act as a radio beacon for a plane or helicopter to guide itself towards. So instead of looking at GPS coordinates or something like that, it basically a navigation station will emit a constant signal on a certain frequency. It'll be picked up by the TACAN antenna, and it will calculate the direction it came from and how long it took to get there, and it will use that information to figure out where the current aircraft is relative to that signal. Now, the way that works here in Stormworks is you have two vehicles, both equipped with the TACAN system. I have another radio test cart over there, and I have this one over here. That one is already set to transmit. In order to use this, there are basically, you're going to need two antennas, one for transmitting and one for receiving. The actual, basically the controller for it got a little bit bigger, and if I remember correctly, it's under here. So, now, as far as the interface of using this thing itself, the way the system works is each vehicle has to have a GPS sensor, which the GPS sensor is also under the cart. And it gives the X and Y coordinates of your current vehicle, and it feeds those coordinates into the transmitter. Then the other vehicle also has a GPS system and its own X and Y coordinates. It subtracts the X and Y coordinates of your current vehicle from the transmitting vehicle, and it will give you the difference in grid coordinates, north and south, so the Y coordinate difference, and east and west being your X coordinate difference. And then it converts those into a squared and b squared, which will give you c squared, which will be your straight line distance between the two vehicles. And then there is a trigonometric arctangent function that will convert that straight line distance into a bearing out of 360 degrees on a magnetic compass. So right here we have our two instrument panels, one for transmitting, one for receiving, an X and Y difference, so north-south, east-west, straight line distance, and bearing. Now, right now, all of these are pointless because it's not transmitting or receiving anything. Now, the other vehicle is set to transmit on 1 and receive on 2. So, we set this one to transmit on 2 and receive on 1. So with that one over there, transmitting on 1 and receiving on 2, we turn on the transmitter so the other one can see it, and you'll see right here, it is approximately 53 meters north and 54 meters east. And we look over here, we have a bearing to target of 225.89. We hold out our little compass right here, and you'll see in the center of my screen at the bottom, the magnetic compass is saying we have a bearing 225 to that vehicle. So, as you can see, the system is correct. I don't have any way of telling you if the distance is correct, so you just kind of have to take that one on faith. But we'll walk over here and look at the other one. As you can see, transmitting on 1, receiving on 2. And it says 52 degrees, 52 meters, 54 meters. Then bearing to target, 046. Turn back around, and 046. So that is basically everything you need to know to use the TACAN system. How you actually set it up. As you can see, everything is connected to electricity. You go to data. We have the X and Y coordinates. That goes into X1 and Y1. Then the rest of the nodes, you have the power to the backlights, and basically just to light everything up. Activating the transmitter, because the thing is, they have to be on 2 different frequencies, one for transmit and one for receive. So, then you have all of these other things. The X1 and Y1, those are your vehicle. Then these are your frequencies, transmitting frequency, receiving frequency. These parts are optional, you don't really need those. They're just cool to have for the purposes of me showing that my circuit works. This is the X and Y difference, so north, south, east, and west. This is your straight line distance. That's the Pythagorean Theorem, the a squared plus b squared equals c squared. That is c squared. And then this is the calculated bearing using a tangent function basically around a unit circle to tell you which quadrant you're in and converting that from radians to degrees. Now, one thing that's probably important to note is it has to be on 2 different frequencies in order for it to work. Like right now, it's transmitting on 1 and receiving on 2. Well, hypothetically, if I wanted to have it transmit and receive on the same frequency, it does this. Basically, it gives you nothing useful, so it always has to be on a separate frequency. The transmitter is only required on the navigation station. Typically on the aircraft, you won't have it set to transmit unless you absolutely need to transmit with it. So say you're coordinating with another aircraft. But, as I said, this is how you set up the system. You need 2 instrument panels, one as a dedicated transmitter, one as a dedicated receiver. The transmitter in the microcontroller is considered panel 1, so either it's on top or on the left, and then the receiver is panel 2, so either the bottom or the right. And then the ones that you absolutely want to have on the vehicle is your straight line distance and bearing. X and Y, those are cool, but like I said, optional. And yeah, that's my TACAN system, or Tactical Air Navigation System. Thank you for your time.